In a series of recent photos, NASA's Hubble Space Telescope has brought us an incredibly rare blast from the past. The telescope captured 3 different moments from a supernova explosion over 11 billion years ago. But how exactly was it able to pull it off? Not just that, but we've also got a list of the supernovae visible to the naked eye. Let's dive into it. Starting with light from an exploding star. The telescope recently captured light from a star that exploded over 11 billion years ago. But it did much more than capture just a single image. Instead, the telescope managed to get a hold of 3 that showed us the fading ball of fire over a week. For starters, the small amount of light from the supernova was first enhanced by a nearby enormous galaxy cluster's gravitational field, Abell 370. Gravity warping in space often acts like a cosmic lens. It can magnify and bend the light from a distant supernova, as in this case, it was placed far behind the cluster. Another bonus for astronomers is that 3 images appeared in the picture as it strung along the cluster. These images show it exploding over different periods, despite them coming to Hubble simultaneously. But why 3 images? As it cools down, it comes across in slightly different colors in each image. These images came over at slightly different times since the supernova's light followed pathways with different lengths. They were delayed because they took a longer path across the valleys of warped space. In universe years, its age is the same as childhood. However, the telescopes have some other neat tricks that make this possible, especially since shooting a supernova is one of the rarest things ever. In short, it can use gravitational lensing. A researcher at the University of Minnesota School of Physics and Astronomy, as well as the first author of the paper, Wenlei Chen, said it's scarce that a supernova can be detected at such an early stage since it's incredibly short. Moreover, gravitational lensing. In the same exposure, they got multiple images showing different phases of a supernova. Since it could warp, bend, and even magnify the light from a distant supernova behind the cluster, it could also make several images of the explosion over different periods. This was only possible because the zoomed-in images took several paths throughout the luster due to the slowing down of time, space curving because of gravity, and the differences in the length of light waves. If we look at the image, we can see a fading supernova rapidly changing its color. As explained by NASA, this shows how its temperature changed. Usually we think that blue means cold and red means hot, but in this case, it's the exact opposite. The hotter the supernova, the bluer its color. That's why it's showing up as blue in the images. As it cools down, it's going to turn redder. Lastly, discovering more about our universe. According to NASA, this is the first time that astronomers have been able to measure how big a dying star can be in the early universe. They base this on its brightness and how quickly it could cool down. Both depend on the star's size. Our universe is currently 13.8 billion years old, and the latest supernova picture we've managed to get isn't even as old as a fifth of its age. It is the first in-depth look at a supernova we've ever gotten from that far back in the universe lifespan. This could be a huge help to scientists, one that lends them a hand at learning more about how stars and galaxies formed in the early days of the universe. They found this supernova by going through the telescope's archives in search of transient events, with both Chen and Kelly and a bunch of international astronomers on the team. The machine learning algorithm to find such events was also written by Chen, but this was the only multiple image supernova they could find. Chen and Kelly have now planned to use NASA's James Webb Telescope to look at supernovae even farther away. They're hoping they can help astronomers understand better if the stars that existed early on differ from those we find nearby. 7 naked-eye supernovae throughout human history. Coming up, supernova RCW86, the oldest recorded supernova. Back in 185 AD, Chinese astronomers were able to see a mysterious star that suddenly popped up in the night sky and was seen for 8 months. But that was all it took for them to take notes of it and record the first ever observation of a supernova in the history of humanity. However, some evidence does point toward Roman astronomers also witnessing it. We've discovered the same dead star's remains once again. Studies show that the supernova RCW86 took place because a neighboring star shot out massive amounts of its matter into the white dwarf, essentially making it a stellar corpse, leading to what's known among astronomers as a Type 1a supernova that took place about 8,000 light-years away from Earth. Combined X-ray images from the European Space Agency's XMM Newton Observatory and NASA's Chandra X-ray Observatory show that a shockwave heated its gases to millions of degrees. Moving on, supernova G347.3-0.5, Chinese guest star. Though it's now called G347.3-0.5, it was previously known as the supernova of 393 AD. It was visible in the night sky, with astronomers estimating that it was probably as bright as the largest planet in our solar system, Jupiter. That's further evidence that this was also seen and recorded by Chinese astronomers who are known for chronicling the Earth's night sky. Not just that, but multiple historical Chinese text reference meteors that killed people back in the day. Additionally, SN 1006, supernova recorded in rock art. The year 1006 AD is one of the best contenders for one of the best times in human history to gaze at stars. In late April, a surprisingly bright star or guest star exploded in the sky between the constellation Lupus. According to NASA, SN 1006 is thought to have been 16 times brighter than Venus. That's usually the brightest thing we see in the sky other than the moon. Moreover, it could be seen during the day with its estimated magnitude of -7.5. It was so bright that people worldwide took notice of it, with evidence of it in records from China, Iraq, Egypt, Japan, Europe, and even some from North America. Some astronomers claim that the rock art we've found at Arizona's White Tanks Regional Park depicts this new star showing up. Similarly, SN 1054, the Crab Nebula. On the 4th of July back in 1054 AD, the entire planet got to see celestial fireworks as a new star appeared in the Taurus constellation. The supernova was at first brighter than the moon, but slowly faded over the next 2 years. A lot of ancient cultures probably got to see the bright object. Some of the most exciting records of it can be found in petroglyphs at Chaco Canyon National Park in New Mexico and the areas around it. Some astronomers think this rock art is again trying to depict the event, though other researchers doubt it. Amateur astronomers to this day regularly view the remains of it, known as the Crab Nebula. They think it could have spawned because of a Type II supernova, which only happens when a lone massive star explodes. Next up, supernova 3C58, seen by ancient Asian astronomers. Supposedly, both Chinese and Japanese astronomers witnessed it in 1181 AD, much like previous historical accounts, and they called it a guest star. Modern imaging of it captured by observatories such as NASA's orbiting Chandra X-ray have shown some great details about what the star left behind after it exploded. The supernova holds a constantly spinning neutron star called a pulsar that's surrounded by a thick ring. The pulsar still shoots out X-ray jets that go as far as trillions of miles to make loops and swirls around the dead star that's still supermagnetic. Let's talk about SN 1572, Tycho's supernova. When it first showed in the night sky back in 1572 AD, the new star was extraordinarily bright and shone proudly in the Cassiopeia constellation. First taken note of by the Danish astronomer Tycho Brahe, he worked on mapping out and measuring the heavens before telescopes were even a thing. His findings pointed toward a new star sitting past the moon. Still, according to NASA, it proved an essential idea, especially when Nicholas Copernicus' idea about Earth not being the center of the universe were taking the public by storm. Finally, SN 1604, Kepler's supernova. The supernova takes its name from the mathematician and astronomer Johannes Kepler from back in 1604. After the new star appeared in the sky, he observed it for about a year. However, it was also spotted in China and a lot of other places around the world. It was even visible during the day. Even today, it's studied by astronomers. While we've got Betelgeuse taking up hundreds of thousands of years to explode and fill the Earth's sky, the stellar time bomb could beat it to that. That's a wrap for this video. What are your thoughts on the supernova? Let us know in the comments below. Make sure to give this video a thumbs up and subscribe to our channel for more videos like this. See you at the next one.